In this section, you are dealing with solving equations, except that it's a special type of equations. It's the equations that has radicals in it. So that's the last section that is in chapter 8. Let's write down the steps so you won't forget. The first thing you want to do is to transfer all the terms to one side, leaving only one radical term on the other side. So you should always have one radical at any one time. So in this class, the radical term that we are dealing with is mostly square roots. So to get rid of square roots, what you're gonna need to do is to square both sides of the equation and simplify. So this is using the property that if a squared equals b squared, if a equals b, then a squared equal b squared. Okay, so it allows you to square both sides. This is what we mean by square both sides. Okay, so what happens is if equation still has a radical term, then you're going to have to repeat steps 1 and 2. So you're going to have to keep doing this until eventually there's no more radical terms. Okay, and so what you need to do is to solve the equation. But the ones that you have to remember, and this is very crucial, you have to check answers for validity. So you have to watch, I guess I should say you should reject extraneous roots. Okay, so don't forget that. Okay, so let's look at some examples and then you're gonna have to practice. So let's do the first one, solve. So let's say the equation is x plus 1 equal x. So according to the steps, you're supposed to transfer all terms to one side, leaving only one radical term on the other side. So what I'm going to do is I'm going to bring the 1 over. So that gives me x minus 1. Okay, so you're supposed to leave only one radical term on the other side. And the next step you need to do is to square both sides. Okay, so when the square and the square root comes together, remember what you learned in the previous section. Square root really means exponent 1/2. So this square root and the square actually cancels each other, leaving you with x plus 1. Okay, and as for this one, on the right side, you now have to FOIL. So you have to think of what's x minus 1 times x minus 1, and you FOIL it. So what you end up with is x squared. So let's do FOILing on the side, and then I'm combining like terms, so that gives me minus 2x plus 1. Okay, that's my FOILing. Now if you notice that this does not have any more radicals on the equation, so we're going to skip step 3. Okay, so step 1 is to transfer all the terms, step 2 is to square both sides. Step 3 is to repeat them if there's still radical term, which we don't have. So I'm moving on to step 4. Okay, so to solve this equation is nonlinear. Nonlinear because there's an exponent, so you must have 0 on one side. Okay, so subtract x on both sides, subtract 1 on both sides. So what that gives me is 0 equal x squared minus 3x. So if you factor out the x, you have x minus 3. And if you put each piece to 0, tells you x is 0, or x minus 3 is 0, which tells you x is 3. So this is the crucial step. You need to check if it works. So supposedly I put 0 into the equation. So square root of 0 plus 1 is that 0. That's what you're checking for. And you notice that you're talking about root 1 plus 1 being 0, which is 1 plus 1 being 0, and that's nonsense. Okay, so in that sense, it's rejected. So x equals 0 is being rejected. So what I have is reject. And now I'm going to check for x equals 3. So check for x equals 3. Square root of 3 plus 1, is that equal 3? That's what you're checking for. So root 4 plus 1, is that equal 3? So let's see, 2 plus 1 equals 3. Yes, okay. So x equals 3 is my only answer. Okay, so that's my solution. There. Okay, let's try another example. Supposedly I say, can you solve, okay, q minus square root of q minus 2 equals 2. Okay, so remember the square root term has to be alone, so let me move things around. I'm going to have the 2 out over here, and I'm bringing the square root over there. Okay, so the idea is the radical term has to be alone. Alright, I think we're ready, so we square both sides. So what you have here is you're going to have to FOIL. That gives me q squared minus 2q minus 2q minus 2q plus 4, and on this side the square and square root cancels, leaving you with q minus 2. So what happens is you need to have a 0 on one side, because this is again a nonlinear equation. So what you're gonna do is I'm gonna subtract q on both sides, and I'm gonna add 2 to both sides, so that this is cancelled, and on this side I now have q squared. Let's combine all the terms. Minus 2 with minus 2 with another 1, so that's gonna be 5q and plus 6. So I'm gonna factor this as q and q, 2 and 3, and then minus and minus. So this actually gives me two answers. Okay, it's telling me q minus 2 is 0, or q minus 3 is 0. So here it's telling me q is 2 or q is 3. So remember to check your answer. So what happens when q is 2? Let's check it. And every time when you check, put into the original equation. Okay, so it's going to be 2 minus square root of 2 minus 2. Is that equal to? That's what you're asking. So 2 minus square root of 0, is that 2? Let's see, 2 minus 0 equals 2. Yes, okay, so q equals 2 works. So let's try q equals 3 this time. Okay, so 3 minus square root of 3 minus 2, is that equal to? So let's see, 3 minus square root of 1, is that the same as 2? 3 minus 1 is equals to 2. Yes, okay, yes again. So in this case, you notice that both answers are okay. Okay, so the solution to this question, there is two. One is 2 and one is 3. Okay, so there's two answers to it. So let's look at the next example that carries two radical terms. So for example, can I solve square root of x plus 7 is equal to square root of x plus 4 minus 3. So the rule of the game is you can only have one radical term on one side. So in this question, there is one radical term on the other side as well, but that's okay, so long as you have only one on one side. And this is the step you have to watch out. You're really squaring the entire side. So on the left side, you can cancel the squares in the square root, but you cannot do that to the right side. Okay, so on the left side, all you have to do is square and square root cancels, leaving you with x plus 7. But on the right side, watch out, because there's two pieces right now. So the only way to get rid of the square is by foiling. So let's make sure you understand how to FOIL this. So the way you have to think is, what is square root of x plus 4 minus 3 multiplied to square root of x plus 4 minus 3. So you have to think like that. Okay, so square root with square root, if you like, you can think of it as x plus 4 squared. Okay, and then 3 times square root is minus 3 square root x plus 4. The 3 goes outside because he's not in the square root, he's not in the radical. Whereas in the first term, you notice they are both in the radical. X plus 4 and x plus 4 is in the radical. So that's why when you multiply them, it stays in the radical. Okay? So let's go again. So the inner term is where I take 3 times the radical. So if you look, the 3 does not have a radical, but so it stays outside. So it's minus 3 radical x plus 4. And minus 3 with minus 3 makes it plus 9. But on the other side is still x plus 7. Okay, so let's try to clean this up a little bit. What I have is the square and the square root cancels, leaving me with x plus 4. The two middle pieces, they combine. Okay, so that makes it a negative 6 radical x plus 4. And then I have a 9 on the other side. Okay, so the rule of the game is you must have only one radical term at one side at one time. So I'm going to subtract x on both sides, I'm going to subtract 4 on both sides, and I'm even going to subtract the 9 on both sides, so that this is cancelled, okay, leaving me with negative 6 radical x plus 4. But on the left side, it's now a mess, but I do cancel the x's. So what I have is 7 minus 4, which is 3, and 3 minus 9 is negative negative 6. So there's two ways you can go about this. One way is to divide both sides by negative 6, okay, so that the numbers are a little smaller. So let's do that. So that makes it 1 square root x plus 4. Okay, so that my radical term is alone. Alternatively, if you don't wish to divide, you can also square it right away, okay, except that you have to be careful. So the other alternative is you can keep it as negative 6 and negative 6 radical x plus 4, and you square this right away. So if you square this right away, this is a 36. Now watch out for this side. The 6 when you square is a 36, but the square and the square root, they cancel. Okay, so you can divide now, or you can distribute. But if you do that, you notice that you get exactly what we get right now, okay, where we square both sides and you get the same answer. So you notice, if possible, you try to divide it first so that the numbers are a little smaller. But either way, it's the same. You get the same answer. Okay, so let's subtract 4 on both sides. So that tells me that negative 3 is x, or rather x is negative 3. So I have to check whether it works. Okay, so x is negative 3. Let's check. Square root of negative 3 plus 7, is that equal to negative 3 plus 4 minus 3? So let's see. This side says square root of 4. This side says square root of 1 minus 3. So square root of 4 is 2. And 1 minus 3, nope, that's not equal. Okay, so for that reason, you reject it. And you had only one answer, but you had to reject it. So end up, the answer to this question is no solution. So I want to show you the last example before you start jumping to the conclusion that you always end up rejecting negative numbers, because what we really need to check is whether the number actually satisfies the equation or not. Okay, and it's nothing to do with it being negative or positive, the value for x. So let's try this one. What if it's square root of 1 minus x plus square root of, say, 6 minus x equals 5. Okay, so let's solve this. So let's recall the steps. You're supposed to keep only one radical on one side, so let's keep this on one side, and let's bring the 6 minus x over the other side. Okay, so I have one radical on one side, so square both sides. Square and square root cancels, leaving me with 1 minus x. But on the other side, because there are two terms, I have no choice but to FOIL. Okay, so let's FOIL it. So I'm supposed to think of what's 5 minus square root of 6 minus x multiplied by 5 minus square root of 6 minus x. Okay, and on the left side, there's not much I can do anymore, but on the right side, 5 times 5 is 25. 5 times square root of 6 minus x is 5 square root 6 minus x. Another 5 square root 6 minus x, and plus square root of 6 minus x all squared. Okay, so 1 minus x is 25. The two middle pieces, they actually combine to make it negative 10 square root 6 minus x. But the last term, the square and square root cancels, leaving you with 6 minus x. Now you're allowed only to have one radical term on one side, so let's bring the 25 over. Let's bring the 6 over, and let's add x to both sides. Okay, so what happens is the 25 cancels and the x cancels, leaving you with negative 10 square root 6 minus x. And on the right side, the x's cancel, so what I have is negative 30. Okay, so I'm going to divide both sides by negative 10 so that the numbers get a little smaller. And what I do now is I'm going to square both sides again. Okay, so 9 is equals to square and square root cancels, 6 minus x. So what happens is I'm going to subtract 6 on both sides, so 3 is equals to minus x. So switch sides will tell me x is minus 3. So again, you have to check before you know if you can accept it. So let's check x equals minus 3. This time, you notice that when you substitute the value, it's going to be 1 minus minus 3 plus square root of 6 minus minus 3, and you're asking if it's equal to 5. Now, when two minuses come together, it actually becomes plus. So equivalently, we're asking you 1 plus 3 square root and 6 plus 3 square root, is that equal 5? So let's see, this is root 4, this is root 9, this is 2, this is 3, so is that equal 5? Yes. So this one actually is a solution. Okay, so make sure not to reject it because it's negative. You really have to check it to know. And the exercises for this section is found on page 390. So I guess I should just say try some problems on page 390. Okay, and I actually gave you some on the review sheet as well, and you can do those too. Okay, and that's the end of chapter 8, by the way.